sample proportion probabilities. Our objective, compute and interpret probabilities of the sample proportion. So what do we want to remember? We want to remember that the shape of the sampling distribution of P, which is the population distribution, is approximately normal provided n times P times 1 minus P is greater than or equal to 10, and provided the sample size is no more than 5% of the population size, which is in mathematics means the sample size lowercase n is less than or equal to 5% times uppercase N, the population size. We also know the mean of the sampling distribution of P hat is equal to the mean of the population. So, mu P hat is equal to P. And we also know the standard deviation of the sample distribution of P hat is calculated as follows. Sigma P hat is equal to the square root of P times 1 minus P over N. As with sample means that are normally distributed, we can use StatCrunch's normal calculator to calculate sample proportion probabilities and values. So let's do that in a couple of examples. Okay, let's see what we got here. And let's make sure that I don't lose track of my normal calculator. Okay, according to a study done by the Pew Research Center, 39% of adult Americans believe that marriage is now obsolete. Letter A, suppose a random sample of 500 adult Americans is asked whether marriage is obsolete. Describe the sampling distribution of P hat, the proportion of adult Americans who believe marriage is obsolete. Okay, so let's take a look. Is it normal? That's the question. Describe the distribution. Is it normal or is it not normal? Well, we check two things for normality. Okay, n times P times 1 minus P, which in this case, n is 500, our sample size. The proportion that are saying that it's obsolete is 0.39 times 1 minus 0.39. That goes into a calculator, and that is 118.95, and that is certainly greater than or equal to 10. Okay, that's the first criteria. The second criteria is 500 adult Americans less than 5% of the population of adult Americans. Second criteria, 500 adult Americans is far less than 5% of the population of adult Americans. So now we can describe the distribution. It is approximately normal. Okay, so the sampling distribution of P hat is approximately normal, and we want things to be normal. Okay, with mu sub P hat equal to P, which is equal to 0.39, and sigma sub P hat equal to the square root of P times 1 minus P. So this is the standard deviation of P hat over N, which is the square root of 0.39 times 1 minus 0.39 over 500, which is equal to, I think I went out to 3 decimal places, 0.22. So now we can deal with this with our normal probability. We have our mean, our sample mean, and our sample standard deviation. Letter B, What is the probability that in a random sample of 500 adult Americans, less than 38% believe that marriage is obsolete? Probability that the sample proportion p hat is less than 0.38. Let's go to our normal calculator. So come into here and stat calculator's normal. And I'll come down to here, open it up. We have our defaults here. So let's put our mean in. Our mean is 0.39, I believe. Yes, 0.39, 39%. Our standard deviation is 0.022. And we want to be less than, it's already selected, less than 0.38. Compute. And the answer looks like it's 0.02. Did I get that right? 0.38, 0.022, 0.39. I think I did. So 0.0347. Okay. So 0.3247 if I carry it out to 4 decimal places. Okay, letter C. What is the probability that in a random sample of 500 adult Americans, between 40% and 45% believe that marriage is obsolete? Probability that p hat is between 40% and 45%. Okay, let's go back to our normal calculator. And I've got it blown up, so it's kind of, we had the same mean, it's 0.39, the same standard deviation of 0.022, but now we want to, we want to go to the between, so I need to select between and come down to here. We want to be between 0.40 on the left and 0.45 on the right. Compute. Looks like I've got 3215. Okay, and you can see, before I take that away, if I go back, you can see this is between the two. There's your 0.4 and there's your 0.45. So there's the area under the normal curve. And go back to here, and it is 0.3215 is what I have. 3215. Okay. Letter D. Would it be unusual? Unusual, remember, that's our 0.05 cutoff for a sample of 500 adult Americans to result in 210 or more who believe in marriage is obsolete. Okay, well, 210 out of 500 is equal to 0.42. So the question said the probability that p hat is greater than or equal to 0.42. That's what we're asking here. 210 out of 500 is 42%, 0.42. Would it be unusual if the probability unusual if that probability is, what is that probability and would it be unusual? So let's find it. Probability p hat is greater than or equal to 0.42. We'll go back to here and I gotta go down, I gotta change it to the standard, not the between. Okay, I've got my 0.39 here, my 0.022. Now I wanna know about greater than, will it be greater than that, okay? Result in more than, okay, 0.42, compute, and I come up with 0.086, 0.086. So I'll go to here and I'll say that probability is 0.086. Well, that is larger than 0.05, so not unusual, not unusual. All right, let's take a look at 2 more examples. And then I think I'm going to do a recap for you. Where do I do my recap sheet? Oh, I know I did my recap sheet. I'll just pull this one here for you. I know what I did with it. I had a recap sheet. I need to make sure I do a recap. Okay, the Pew Research, example 2. The Pew Research Center recently reported that 18% of women between the ages of 40 and 44 have never given birth. Suppose a random sample of 250 adult women between 40 and 44 results in 52 indicating they have never given birth. Explain why this is not necessarily evidence that the proportion of women between 40 and 44 who have not given birth has increased since the time of the Pew study. So basically explain why this is not necessarily unusual. Well, let's take a look. So 52 out of 250 is equal to, I like to put a 0 in there first, 0.208. Okay, I'm not going to do it, but we can check our n times p times 1 minus p, and that should be greater than 10. And of course, 250 adult women is way less than 5% of the population, so we're normal, and so we can do our mu sub p hat. That's going to be 0.18. That's right here. And we can do our sigma sub p hat, our standard deviation, square root of 0.18 times 1 minus 0.18 divided by the sample size of 250. And so we get our two parameters, our two statistics that we're going to use in our normal calculator. And we want to see the proportion greater than this. Okay, if it's greater than this, if that proportion, if we want to see, expect this not necessarily evidence, it is increased. So we want the probability that p hat is greater than what we came up with here, which is our proportion. And that goes into our calculator. I'm going to assume you know how to do that at this point. And up comes a result of 1246, which is greater than 0.05, so it's not unusual. That's usual. So the evidence is insufficient. The evidence is insufficient to support that there's been an increase. Okay, last problem we'll take a look at. We'll have to deal with the size we're looking for. Let me get this up here so we can all see it. A researcher studying ADHD among teenagers obtains a simple random sample of 100 teenagers ages 13 to 17 and asks them whether or not they have ever been prescribed medication for ADHD. To say that the distribution of p hat, which is the sample proportion of teenagers who respond no, is approximately normal, how many more teenagers does the researcher need to sample if they want 90% of all adult Americans to support the changes? Okay, and letter B, 95% of all Americans to support the changes. Excuse me. Okay, well, we know that normal is NP times 1 minus P. This is one of that's the key piece that speaks to normal and that ties in how many we need. Okay, so let's solve this for n. I'll divide both sides by P times 1 minus P, P times 1 minus P, and n must be greater than or equal to 10 divided by P times 1 minus P. Okay, well, let's see. Our first P is 90%. So A, I want N greater than or equal to 10 divided by, let's see, P is 90%. So 0.9 times 1 minus 0.9. And N must be greater than or equal to, that goes into a calculator, obviously. And the answer is 111 with more. So that basically goes up to 112. Okay, this is saying you need 111.11 people to do this. Okay, well, once you get above 111, you're going to 112. Well, we were talking about 100. How many more does he need? 112 minus 100. We need 12 more. We need 12 more to get to a 90% level. Okay, we need 12 more in our sample. Letter B, we want 95%. Okay, so we'll do the same thing. N is greater than or equal to 10. In this case, it's 95, so 0.95 times 1 minus 0.95. So N is greater than or equal to, and this answer, I forgot to write it down. Let's take out my calculator. I thought I have it here, clear. Let's go up to here. Where'd it go? Okay, I did do it. It's 210.53, which means we need 211. Okay, so we take 211 and we subtract 100. We need 111 additional. How many more? 111 more people. Okay, so that's using this formula, that's using this NP times 1 minus P greater than or equal to 10 to talk about the sample size that we need.